Alright, here's a fun one. You've got a bunch of kids, each with a greed factor, and a pile of cookies with different sizes. A kid is only happy if their cookie is big enough for them. We want to make as many kids happy as possible. And here's the key insight: this is a classic greedy problem. If we think about it smartly, we should give the smallest acceptable cookie to each child, saving the bigger ones for greedier kids. First things first, we sort both arrays. The greed factors and the cookie sizes. Why? Because sorting lets us match the least greedy child with the smallest cookie that works. Think of it like lining up kids from least picky to most picky, and cookies from smallest to biggest. Now we can just walk through them in order. Here we set up 2 pointers, one for the current child we're trying to satisfy, and one for the current cookie we're considering. Both start at 0, meaning we begin with the least greedy child and the smallest cookie. Super simple, right? These 2 pointers are going to walk through the sorted arrays together. Now watch what happens. We loop as long as we have both children left to satisfy and cookies left to try. The moment we run out of either one, we're done. There's no point continuing if there are no more cookies to give, or if every child has already been considered. Here's where the magic happens. We check if the current cookie is big enough for the current child. If it is, awesome, we move to the next child because this one's now content. We increment the child pointer. Think of it like saying, "You're happy? Great, next kid in line please." And this is the key insight: whether the cookie worked or not, we always move to the next cookie. If it satisfied a child, that cookie's used up. If it didn't satisfy the current child, well, it's too small for this kid and every greedier kid after them, so it's useless. Either way, we're done with it. Finally, we just return the child pointer. Why does this work? Because the child pointer only advances when a child gets satisfied. So whatever value it ends up at is exactly the number of content children we managed to feed. Elegant, right? Time complexity is O, n log n plus m log m. Because of the 2 sorts, that's the most expensive part. The while loop itself is just O, n plus m. Space complexity is O, 1, if we ignore the sort's internal space. The big takeaway here? When you want to maximize matches between 2 groups, sort both and greedily pair the smallest with the smallest. That's the greedy pattern. Local optimal choices lead to the global optimum.